I make it 1 minute past the hour, so I'm going to say, well, let's get going. Welcome, everyone. Thank you for joining us. This is the live SYCL panel at IWOCL and SYCLcon for 2021. This is the 9th year that we run this conference, which is just amazing. It feels like we just started it yesterday, and already this is the 9th time we've held this. We've kept growing. It's great to see the way that SYCL's been growing over the last few years, so that we now have, for the first time, a live panel specifically focused on SYCL, which is great. My name's Simon McIntosh-Smith. I'm from the University of Bristol in the UK. And without further ado, I'm going to introduce the panel that we have today. I'm just bring up a slide so you can see who everyone is. Here we go. And what I'm going to do is I'm going to run around, and when I mention your name, if the panelists would unmute themselves and then just give a very quick introduction to who they are. So Michael, would you like to go first?
Hi, welcome to everyone. My name is Michael Wong. I'm the SYCL Working Group Chair and a distinguished engineer at Codeplay. Thank you.
Thanks, Michael. Ronan, you're next.
Welcome everyone too. I'm Ronan Keryell, and I'm a principal software engineer at Xilinx in the research labs, where I work on some SYCL implementation on various hardware, and then also the spec editor for the SYCL specification from Kernels, and we are interested in SYCL because it allows us at Xilinx to do hardware, software co-design, and since it's pure C++, it allows us to do some experiments before we have the real hardware, for example.
Thank you, Ronan. Aksel, could you say a few words, please?
Hi, I'm Aksel Alpay. I work for Heidelberg University, and I created the SYCL implementation of SYCL, which is a project that we're, well, that's an ongoing development, and of which I lead the development.
Thank you, Aksel. Peter, over to you.
Hi everyone, I'm Peter Thoman from the University of Innsbruck. I lead the development of the Celerity project there, which is basically some middleware which extends SYCL in order to easily get to clusters of accelerators.
Thank you, Peter. Hal, could you say a few words, please?
Sure. Hello, everyone. I'm Hal Finkel. I'm a program manager for computer science in the U.S. Department of Energy's Advanced Scientific Computing Research Program. And I think up until last year, I was on the Kronos SYCL committee, and SYCL is an important part of our ecosystem.
Thank you, Hal. Tom, could you introduce yourself as well, please?
Yeah, hi everyone. I'm Tom Deakin from the University of Bristol. I'm a postdoc researching in the field of high performance computing. Like most people on the panel, I'm part of the SYCL working group as well.
Thanks, Tom. And then last but not least, James, if you'd say hello.
Hi, I'm James Reinders. I live in Portland, Oregon in the States. I worked with 5 other guys on a SYCL book using the DPC++ compiler. So thank you to the attendees and panel members who helped us with material and review, and hope you've taken a look. And after I worked on the book, I decided to rejoin Intel to help with all this fun and promoting open heterogeneous computing.
Great. Thank you, James. Thank you, panel members. Now, for everyone in the audience, this is really all about giving you a chance to put your questions to the panel. We've got a really nice range of different panel members from some companies who are providing SYCL implementations. We've got some people who are SYCL users, many people involved in the SYCL standard itself. So this is a brilliant opportunity to put your questions about SYCL, anything that's relevant to the panel. So if you could use the Q&A interface in Zoom, so don't put things in the chat because we won't see that. But if you start putting questions into the Q&A interface, I'll see those, and then I'll pick those out and I'll put those to the panel, and we'll be able to answer your questions for you. So start thinking about what you'd really like to ask the panel. In the meantime, I've got something to get things going for everyone, which is obviously SYCL's had a lot of exciting developments in the last few years, recently with SYCL 2020, and there are lots of really exciting new features in that. So which features does the panel think are the ones that are going to make the biggest difference in sort of helping to promote SYCL adoption and why. So what are the best new things about SYCL 2020? Who'd like to have a go at that? Michael, would you like to have a first stab at that, and then I'll open up to everyone else?
Sure, that sounds like a great opening question. I was just going through so many of the talks at this wonderful conference, and I want to say that I love the idea that now SYCL can support different kinds of backends, and we already have them. This is so amazing. Peter Thoman, who's on the call, actually is now doing a SYCL for Vulkan backend, something that I heavily alluded to in my last State of the Union address, and people just jumped in and picked up on it. Having said that, I think there's so many other great features that makes now SYCL 2020 much more expressive and much more compatible with modern C++ programming. I want to give a chance to other people to jump in and add their favorite features. Thank you.
Yeah, who else would like to comment on that? Best things about SYCL 2020?
I mean, I think SYCL 2020 made a major step forward towards making SYCL a real first-class HPC programming environment. I mean, the addition of things like support for reductions and unified shared memory, the workgroup enhancements and so on. Like, these are things that you really need to write high-performance programs for high-performance and scientific computing. And I think those are all really significant contributions. Of course, also just the sort of better compatibility with modern C++, right? It's also a huge step forward. So those are all very important.
Thanks, Hal. Anyone else like to comment?
Yeah, one thing, I agree, those were top of mind things, but the one thing that wasn't mentioned that I think a lot of users benefit from is connected to what you said, Hal. The modern C++ gives us CCAD, and that really makes the code look a lot nicer and more approachable, especially for people that aren't deep C++ aficionados.
And for people who are not, that's class argument deduction. So it makes things very much more succinct and easier to read and to write.
Yeah, and I would say that was probably one of the top things feedback gave us was, we love SYCL, but and even though it's already less verbose than most, can you make it even more less verbose? like all these other accessors when you don't really need them. So that's great. This is why we jumped on the idea of using class template argument deductions, deduction guides, and extending to that idea USM, unified shared memory, to enable less verbose code, just simplify patterns.
Good. Well, we've started to get the questions coming in now, so let me start going through those. And I think for those of you in the audience, you can upvote certain questions. So if there's a question which you think is relevant to you, you can click the thumb button, and I think it will start to push that one towards the top of our list. So do consider that. So there's actually a question which follows on from that discussion about SYCL 2020. It says it was a great step forward for SYCL, solved many issues we had before. However, it seems that SYCL images have not improved so far, or at all. Even basic features like one component images or read-write access are not available in SYCL 2020. So any comments on that? Seems to be to do with images and SYCL 2020. You can comment on that. Anyone know anything about the image part? We tend to talk about.
Work in a company not involved in images right now. Might change in the future.
So yes, this is what Robert say is true, that that images need some improvement, and that is something we have been debating back and forth. Some of that has to do with the fact that we still have some dependencies with OpenCL images, and that is why that this is not a simple issue for us. And there are GitHub issues. I don't know if they're GitHub, but I think internal GitLab has a number of issues that deal with SYCL images right now that is still pending and is still under a large number of discussions. I know some of you guys might remember. I don't know if Aksel, you remember some of these discussions?
Well, I also don't have particular high stakes in images because it requires a huge engineering effort to implement, and it's still sort of relevant for more of a niche of codes. So it's not something I focus on at the moment.
So this might be an area where maybe if Robert, who posed the question, if you've got some feedback there on use cases, that would be really good to feedback. Now, Michael, what's the best way for people to get involved? Because there's the advisory panel, isn't there, which Tom chairs. Could we get people involved with that?
Yeah, absolutely. It would stuff like this kind of very specific information, you can do it 3 ways. I love the advisory panel, and we're going to make it much more connected and active. I think from the discussion that we had on Tuesday, we're planning to try to make it maybe a quarterly now discussion, and so that we can make the feedback go both ways. I'm going to let Tom talk more about that actually, but the other 2 ways I want to say is the GitHub, the public GitHub is the first way for you to inject requests for new features or fixes. Put it right there. And if you're shy about using GitHub, there's the Sickle form on Kernels that you can just put a question to. There are people that's watching that, and they'll pull people, but all they're going to do is they're going to transfer most of these questions over to the GitHub. So you might as well just go to the GitHub now. Okay. So I think Tom might be able to say more about possible future intentions, because he's now the chair of the advisory panel.
Yeah, thanks, Michael. So yeah, the advisory panel forms quite an important role in Khronos to help bridge the gap between the working group and the users and people that actually want to write using the standards that Khronos are producing. It's a way of increasing people's involvement with Khronos on a more formal basis. So if you're willing to sign up to the IP framework and sign the Khronos NDA, then the working group can share more information with you, and we can take a lot of direct advice under that sort of framework. And it's all zero cost as the advisory panel. So it's zero cost, but you have to sign up to the NDA basically, and that means that the relationship can be very close. We're hoping that lots of people can then eventually decide, well, SYCL is really important to them, and we want to directly have a say in the working group, and you can progress to becoming a more sort of fully fledged paid up member of Khronos too. But yeah, if you're interested in joining and telling us lots of things about what you need in SYCL, then have a look about joining the advisory panel. Michael, in his keynote, which there's the YouTube video you can see, has all the links for getting in touch if you're interested. Be good to hear from you.
Thank you, Tom. And Robert sort of expanded to say that fast images are fundamental for the healthcare industry. So that was interesting to know where that came from. So Robert, please do get in touch. It sounds like people are really interested to hear more about what the needs are. Thank you for
if I might interrupt, yes, I think we definitely need representation from the medical healthcare segment for things like imaging computings and images. We have representations across various aspects, and I want to say that the way a committee like this works well is if you have representation. It's hard for us to do things when we don't know what that area is about. But when people come in, it really helps to drive the direction of that committee.
Yeah, and even inside the Khronos group, there are obviously many other groups working on images. And up to now, we've been busy with developing SYCL because of its own problem, but now it becomes more steady state. Then we can collaborate probably more with Vulkan or Anari for the HPC and images seems a good working group, because it's about a kind of computational graphics rendering, and so probably a good people to work inside Khronos to develop this image support with HPC interaction.
Yeah, that actually is why I mentioned Peter Thoman's work on, is it called SYCLcon? That's right, Peter.
Okay, yeah.
Yes, that's what it's called.
It's kind of like trying. I loved it, but I want to see if you can say some more about where that is. And it kind of allows you to marry compute with graphics now, and enabling is that what it does? I think, right?
Yeah, first of all, it enables you to use any device which just supports SYCL, of course. So that was one of the goals we had when we made it. And another thing is that actually previously I had a project where I really wanted to use hardware ray tracing, and you couldn't really use that in any combination with SYCL. And together with the backend interop, in SYCL 2020, if you had a working Balkan backend, you could, for example, use hardware features like that, where it will probably take a while or never come to native SYCL. So that was one of the ideas behind that.
Thank you. I'm going to come to the next question now, because it sort of leads on from this in a way. From Joachim, how do you plan to increase SYCL library portability across implementations? And that's now that we've got a nice proliferation of implementations, how can we guarantee SYCL library portability, or at least increase that? Any comments on that?
Maybe I can get started.
Yeah,
I think a problem in this regard is twofold. Like, one is that historically, for a long time, Compute CPP was the only SYCL implementation that was production ready, which meant that many of those early libraries were exclusively tested with Compute CPP. And nowadays we have the separate problem that everybody is sort of racing to SYCL 2020, but doing so with different feature prioritization and at different levels. So that means that the SYCL 2020 interfaces that one implementation supports are not necessarily the same as another implementation supports. And that means that it's at the moment sort of a bit difficult to write software that works with any SYCL implementation. But I think that this is ultimately a temporary problem. Once all implementations have sort of aligned and library developers can easily test with multiple SYCL implementations, then that should improve. One thing that we could do in the meantime, for example, I think is improve documentation. For example, say which SYCL implementation supports which features and with which interfaces, for example, to make it more clearer for library developers which features they can use, or which restrictions or which impact using a certain feature would have regarding portability.
Thank you, Aksel. James, obviously Intel has a very diverse range of libraries that it provides as part of the One API. How do you deal with things like library portability across different implementations?
Well, first of all, I agree with what Aksel said. The driving to the SYCL 2020 standard will get SYCL lined up a lot better. But yeah, One API is a broader issue, and I would say we work very hard to provide the same interfaces on multiple devices across multiple OSs. But I think at the end of the day, you can't do everything everywhere, and you don't want to, race to the lowest common denominator. So it's really important to publish and be very clear about, what is supported across devices. And throw into the mix, I think the other interesting thing that we hear from users is host versus device side APIs. And there's a lot of desire to see the same API in both places, but we're learning how to do that without driving people insane as well, with the differences that might be obvious there. So stay tuned. I think this is something that we all need to work towards. As I said in my keynote, I very much believe that as we work together as a community, we can really drive to make sure that whatever APIs we come up with, that we can support them on all devices for all vendors, and yet have the ability to specialize. But that commonality will help all of us.
I think.
Go ahead.
I think that one particular thing people can do if they hit a compatibility issue that is very useful and meaningful is contribute some sort of testing for that, if at all possible, because that will ensure that in the future, at least, that particular compatibility issue goes away.
Thank you, Peter. Tom, I know you ported a couple of different codes to different implementations, including things like Babel Stream. What's your experience been at trying to get things work across different implementations?
Yeah, so far things have gone quite well. We have a paper at IWOCL, actually. One of the PhD students in the group at Bristol has been trying to run some benchmarks and track how all the implementations that we can get our hands on have been doing. And generally, if you write standard SYCL, then it's going to work across all the implementations, and the conformance test suite that's going to be released as soon as it's ready will allow those implementations to give you that guarantee back as well, to say my implementation, the compiler and runtime you're using will run, vanilla SYCL code correctly. So yeah, that's what we've found. Things are going well though.
Thank you, Tom. And actually, I can see Philip Saltzman's expanded on the original question, mentioning the conformance test. So thank you for mentioning that. Good. I'm going to jump down to this sort of a connected question about how can you work with SYCL if you depend on an external Cuda library. So far, the only option we see is porting that external library to SYCL as well. So that I guess maybe you'd expand that to how can you get SYCL to work with other languages like Cuda, or maybe it's OpenMP or something else. Is there a way for SYCL to interop with other languages? What's the vision long term?
You said it actually. It's the interop feature, the backend interop feature in SYCL 2020 that's going to enable that kind of transition. So we think that's what allows us to do that. I mean, certainly some people are going to port it to SYCL, but with this capability, we think that we can open ourselves to other things like OpenMP, as you said, and certainly Cuda.
Okay, so there should be a route then to actually be able to interop with other languages, other libraries, and not require everything to be in SYCL. And is that already there? Is that something people are working on at the moment, or what's
so I think other people. So Ronan has his hand up, so maybe.
Yeah.
Yeah. So that's an interesting topic, and we can connect SYCL either at the program level or at the concept level with some other tools. And for example, there are the multidimensional arrays coming into C++, and at the same time, in Fortran 2018, now the interoperability with the C API can expose the multidimensional arrays of Fortran directly to something else. So it's pretty exciting to, for example, to process sub arrays from Fortran to C++, SYCL, and of course in Python you have NumPy, multidimensional arrays. So there are some way probably to do this, considering just SYCL as a C++ program connected to all the other worlds through the C and C++ interoperability level. But there is a more conceptual interoperability view, or perhaps we could externalize this SYCL concept to some other languages with the same capabilities. For example, in Python, it could be easy to develop this concept of accessors and parallel for and things like that. So, but with all this open source world around SYCL, it would be interesting to see how all this stuff can evolve, but it will not be done by the committee. So that's why probably we need a lot of implementers like you guys to do this too.
Thank you. Aksel, go ahead.
Yeah, I just want to go back to the original question on Cuda libraries, because I think there are two angles here. One is if you're dealing with a library that's not header only. So in that case, you would probably want to extract some Cuda device pointers and some Cuda stream or so, and then tell the library, use this memory, use this Cuda stream. And this can exactly be done with SYCL 2020 interop API. And this is supported, for example, both in DPC++, Cuda backend, and in HipSYCL. So this is something you can use today. If it's something like a header only library, a template library, maybe even, then you're in the question really with how can a SYCL compiler work with the Cuda language? And then there are different implementation specific answers to this. I think DPC++ supports this to some extent, but I don't think you can mix SYCL kernel code and Cuda kernel code, but maybe James can expand on this. in SYCL, you can actually do this. So you could even have call a Cuda template library from your SYCL kernel if you wanted that. So in any case, there's absolutely no need to reinvent your library.
That's really helpful. Thank you, Aksel. Great. Just before we go on to the next question, we've actually got, while this is a chance mostly for the audience to ask the panel questions, we're also going to ask the audience questions. So we've got a couple of poll questions for you all. So Tim, if you can hear me, I think this is a good time for the first question. So this is multiple choice, but you can pick more than one option. So what are your favorite new SYCL 2020 features? And you can pick any of these. Hopefully you've got an opinion. I'm going to do it myself now. Let's see. I'm not going to tell you what I'm picking, because I don't want to influence you all unduly. Let's see. No, I've submitted mine. And then once everyone or most people have done that, we'll show you the results of the poll. So, and we've got a few questions like that we'll ask you as well as we're going. There's a question that I think I can see James is typing an answer to. It tells me why doesn't DP C++ support the standard CMake integration with AddSYCL to target? That's quite a technical one, James. I don't know if you're trying to tackle that one or if you're just pointing them at someone else.
No, I was going to type an answer, but it's hard to multitask. Parallelism can be difficult. The simple answer is we haven't driven the changes back that are needed for that. So I think that's great, an example of great input, and that would simplify things. So I'll take that back with me and see if we can't get that taken care of this year, because we're looking, you race to get all these things done. And of course, all of us that have compilers are still working to figure out when we can get all the SYCL 2020 features in. So it's good to get feedback like that of the rough edges we need to smooth out to make life work. So yes, that should be in our future. So I'll take that back and see if we can't have a better answer next time. Then just stay tuned.
Excellent, thank you. What's the next one that's got the highest ranking is, do we need an implementation of SYCL in upstream compilers for SYCL to really make it? So SYCL in upstream compilers, is that necessary for SYCL to really sort of be mainstream? Oh, we got the results. There we go. You can think about that for a second. So what's proved popular? Unified shared memory, the reductions, yeah. Expanded interoperability, multiple backends. That's interesting, isn't it? Not many others. Yeah, good, cool. CTAD, simplified use of accesses. Very interesting. Maybe not quite as spread as I may have expected. They're kind of all pretty popular. There you go.
This is great. If I can comment, these are some of the top features, the major marquee features in SYCL, and the fact that USM is right up there tells us how important it is. People really want to be able to port pointer-based or CUDA code or something like that. USM has more use than that, and we plan to make. I think, not speaking for the working group, but I think for myself, I think we plan to expand on it and improve on it to other cases. But it's certainly interesting that this is so welcome for so many people.
Yeah, very good. Thank you. So we'll have another question soon. In the meantime, so we'll come back to the do we need an implementation of SYCL in upstream compilers for SYCL to really make it?
Yeah, Simon, let me just provide a quick answer to this from my perspective. So, obviously making it is not a binary thing, right? So, things grow in adoption over time. I think if you want to reach this highest level of adoption, where when people are designing new hardware and designing the programming environments for new systems, it's sort of a of course thing. Like, of course we will, port the SYCL runtime and the environment to work on our system because it's just part of the ecosystem. Then yes, for that I think you really need to have SYCL as part of the sort of base implementations of the various compiler packages. But I think that at different points on the spectrum, we're going to have different levels of adoption, and we're already seeing growing adoption, and I think there'll be more.
Well, thank you, Hal. Anyone else like to comment on that one? Anyone got a prediction about whether SYCL will end up completely upstreamed? And if so, when?
Well, not a prediction, but we've basically had SYCL as our backend for Celerity since the very beginning of SYCL. And comparing then to now, when you tell people about it, you no longer as often get basically a blank stare and the question, what is SYCL? So I think the trend that I see from that is very nice. So hopefully it will continue.
Cool. So you've seen progress. That's great. Excellent. So let's go back to some more questions. Do you see execution prioritization and QoS control features coming to SYCL eventually? So we're going to get prioritization and QoS control features coming to SYCL. Anyone been talking about those in any of the future standards discussions?
So is this kind of referring to something like executors from C++? Then if that's the case, yes, because we are strongly following executors. Executors is this group of features in C++ that allows you to decide when, where, how execution is going to take place. And I think this is something that we've actually contributed to, and other people have as well too. And it's now largely coming to fruition, possibly for C++ 23. We had hoped that it would come in for C++ 20, but we're pretty sure that it could come in for C++ 23. And so in that case, that would give us some amount of prioritizations. I don't know what is meant by QoS control features.
Well, I mean, I think, Michael, if I can speculate a little bit,
Sure.
you know, in some use cases, if you schedule a bunch of asynchronous work, right, you may want the system to prioritize some of those tasks over others. And you may also have timing constraints on some of those tasks, whereas you don't on others, and so on. One complication here, of course, is that many of the devices that SYCL targets have hardware schedulers or other sort of lower level features that influence how tasks are scheduled. And so it's not clear to me how much you can abstract that in a way that's useful for use cases that have tight requirements, but anyone else can comment on this as well.
Mm-hmm.
So if I may comment, I think that this is would probably be a relatively natural extension to the SYCL task graph model to add support for execution priorities or something like that. How well this is then mapped to the hardware is backend implementation specific thing probably, but I think that it might be an interesting idea to at least expose some sort of scheduling hint or something like that for the runtime to take that sort of information into account. So I think that's great input.
You know, we started looking at this. Gosh, it's probably, the time flies, probably 6, 7, 8 years ago on TBB. And when I first got asked the question, to be honest, I thought it was a little strange. But the people were asking, we were able to find some generic ways to do it. And I think based on that experience, I think that would be a really good discussion to have on SYCL, what you can do in practice. It kind of surprises me how simple some of the things we were able to do had real world benefits for people. At first, it looks like an intractable problem, like you can't control everything, but I think this is worthy to take a look at. I think it's exciting when the users of something like SYCL ask questions like this, because they're trying to get real world work done outside of HPC, because who cares about real time in HPC, right? It's all about throughput, but there are people in the world that care about those things. And I think there's some real cool things discussions we could have there. And Aksel, your task graph thing in HipSYCL would be a logical place to experiment with that too, obviously.
Yeah. Awesome, thank you. Daniel, it might be really good if you expand your question as well to include maybe what the use case is. And then that might be really great to feed into these guys as well through the mechanisms we were talking about earlier on, to either through the GitLab website or through joining the advisory panel, something like that.
Yeah, absolutely. I want to emphasize that, Simon, because yeah, when we did this with TBB, it was the actual users that had actual things they were trying to solve that made it concrete enough for us to figure out how we could actually make progress on what felt intractable as a general problem. So
yeah.
we would love that feedback. Absolutely.
Great. There's another question which is rising rapidly through the list, which is NVIDIA is claiming that pure ISO C++ code is the only portable option for heterogeneous computing. Are they right, or is there a place for SYCL? That's a really good panel question, isn't it? I like that one. Who would like to have the first go? Oh.
Yeah, so that's a very interesting question, but I guess even for normal C++, there are a lot of stuff you can do on very low-end devices, and I think we will have the same stuff around heterogeneous computing, because the NVIDIA GPU are very high-end devices, so probably they can cope with fancy high-end memory models with sharing everything, but that's probably very difficult if we want to be really an inclusive standard to support this across any kind of devices.
I think your noise cancelling headphones were working really well there, Ronan.
Sorry, I'm attacked.
Yeah, thank you.
Yeah, so I think just to jump in quickly, this is like, and the Starship Enterprise is the best way to go to other planets, but we don't know how to build it yet. So the presumption here, of course, is that ISO C++ is a thing that could be used right now for real world heterogeneous programming, and the reality is that the support there is still relatively new and modest, and so experience from building things like SYCL and DPC++ and HIPSYCL and all these other standard implementations plus their extensions are going to inform what happens in ISO C++, and so eventually that might indeed be correct, but it's the experience that we get from building all these other things that will eventually, likely many years from now, lead to a situation where pure ISO C++ is a viable platform for heterogeneous programming.
Thank you, Hal. I see Michael's got his hand up as well. Go ahead, Michael.
Thank you. I love this topic. I'm glad somebody asked it. Everything what Hal says, yes. And to put it in context, things takes a while in ISO C++. And what we have there is the beginning of something that can work for heterogeneous programming coming from many, many people's experience. And that's how ISO is meant to work, okay? The reality is for it to be fully supportive of true heterogeneous devices, even for one vendor, probably would be still 3 to 6 years, probably more on the 6 to 9 side, given the fact that ISO has C++ has a 3-year cycle of each release. Having said that, we need heterogeneous programming now, and we need it on many different kinds of devices, from all the way to the high power, big HPC systems, to the small embedded, to the FPGAs, and everything in between for ML. And we have found out that each one of these requires pretty unique optimizations. So I think there will always be a place for something like SYCL that forges ahead and looks at these things and then brings them into a reference standard. And that's where this thing that just pure ISO C++ will do it for all devices is not easy to do, even if it were true today. I think it will be true in the future, and we all want that to be true. And I think we're all working to that. Everybody on this panel is, or almost everyone on this panel is kind of on the C++ committee. I've been there for 20, 25 years. And that is something that I've found out that a lot of people want to happen, but it will take time. Yeah.
Thank you, Michael. Excuse me. James, did you want to comment on that as well?
Yeah, absolutely. I'm a huge believer that putting something in a standard like C++ should be codifying practice, not theories about how to solve problems. So I see SYCL as the perfect proving ground. Much as OpenMP has helped prove things, and OpenMP is pragma based, so that's not going to show up in C++, right? So SYCL is super highly aligned to C++. I mean, to a fault. I love reading in the spec, like, if C++ does this, basically, then SYCL does this. SYCL committee has gone way out of its way to make the path to C++ really smooth, but we need to get these implementations. The questions that are getting asked, what about interoperability? I think we've got work to do on our caching models to make people really happy, because when you have a diverse set of hardware, they have different ways of trying to get performance. We need to prove those out by the openness of the SYCL committee. So I think SYCL is the perfect place. So I think I would suspect we agree more than anyone that this should show up in C++. It's just that let's get it proved and worked out before we codify it in the C++ standard and live with it the rest of our lives. And Simon, you were saying something kind of related to that earlier. It's the question of upstreaming, and I'm really proud to be associated with the DPC++ project, which is a project to upstream SYCL support into LLVM. I mean, where else would you want a compiler to be, right? And I think the community, one of the lessons I've learned over several decades of trying to promote a compiler from Intel that's been very successful is people keep asking, well, why isn't it in GCC? Or the modern way of saying that now is, why isn't it in LLVM? So I think, SYCL's got a number of things going on that will help this. One is getting it into LLVM is going to help a large swath of community, and the other is the tight alignment with C++. So I think we're on the right course, but as Michael said, this doesn't happen overnight.
And I'll add one more point before I go in that thanks to your reminder about what the choices we make. Whenever we come to that crossroad in the working group, should we go something that's non-C++ like or C++ like? We always choose C++ like. Just last week, not revealing anything super secret here, but we were trying to decide, well, where should we place the attribute tag for a non-lambda function? Should it be, and we had kind of done it in such a way so that it doesn't look like what C++ was going to go with, and we uniformly decided to switch it back to the way where C++ was placing that attribute tag. And that's a very important, those little things are very important in our decision in terms of trying to stay as close to C++ as possible. Whenever we have to have a choice, we try to make sure that we debate it and say, we want to go to C++ way.
Thank you, Michael. Now that feels like a good point to ask our second question of the audience. So Tim, if you're there, I think this might be good for the poll question 2. We can bring that one up. So which SYCL implementations are you using? And this is, again, you can click more than one. I'm going to fill this in myself. Which ones have I been using recently? There you go. And none is a valid option, or other. If it's other, we're really interested. There you go. So we'll let the audience do that. In the meantime, there's a question from Nikolai about what are your ideas about the future of hierarchical data parallel kernels, which I think it says are not in SYCL 2020. So hierarchical data parallel kernels. Go ahead, Tom.
I'll start with that one. So first of all, these are in SYCL 2020. There's lots of things there. Pretty much everything in SYCL 2020, or at least everything in SYCL 121 is backwards compatible with SYCL 2020. And this includes the hierarchical data parallel kernels. They are in SYCL 2020. And if you want to use them, you can. There is a note in the spec, as you've correctly observed, that as we've been trying to implement these across lots of different devices, both with compiler-based implementations and library-based implementations, both of which are really important to the SYCL working group, that those are different ways to implement the standard. There are some challenges with the current API for getting good performance on all of the devices that we care about with those APIs as they are in SYCL 2020. So the plan is to going forward it's important to us as the working group that we look to see how we need to write those APIs to make them work well for everybody, no matter what device they're running on.
So they exist, but they hopefully they're going to keep evolving and improving.
Yeah.
Cool. Good. Any comments from anyone else about hierarchical data parallel kernels?
Definitely a work in progress, but something that's extraordinarily promising. It's going to take more work.
Then I'll skip down. Oh, here we go. We've got some results. popular implementations. So we've got DPC++ is the one in front at the moment. And then I think HipSYCL takes second place there with the audience. Cool. And then we've got Compute CPP just behind, Tricycles there. There is another. Ooh, we've got to find out what the other is. And it's nice to see we've got some people with none. So we've got people here who aren't using SYCL yet, which is great. You're all really welcome. And hopefully you'll get to try one of those other ones real soon. That's very interesting. Thank you, everyone. Great stuff. So I'm going to jump to a question which I think James was starting to type an answer to. What's the priority of non-HPC applications in the SYCL committee, i.e. non-HPC user applications or non-HPC libraries?
I thought this might be a popular question for the panel. And maybe this isn't the perfect answer, but I know that FPGAs stretch our imaginations a bit, which I think really strengthens the legitimacy of the SYCL standard, is looking at architectures that aren't just CPUs and GPUs. And I get to see with customers some extraordinarily promising developments on the FPGA side in terms of using SYCL to address some things. And I know OpenCL had a big push on FPGAs, and it left a few things unresolved. And I think SYCL is going to take FPGAs to a space that OpenCL didn't. It's going to deliver on that promise. And in particular, I see, it marrying very well with companies that have VHDL programmers, but then want to do the algorithms, some of the key algorithms in SYCL. And it has some non-obvious effects. It's a very effective team combination that wasn't obvious to me at first. I think we'll see that, and that, to me, that feels different than what I see with HPC, even though I know FPGAs get driven into high performance situations. That was the top of mind for me, but I figured some other panel members would have some ideas too of what our ambitions are for SYCL in non-HPC situations.
I can see Michael has his hand up. Go ahead, Michael.
Sure. I actually want to also hear make sure everyone has a chance to answer this, but for us, and in my talk, you'll see that I highlighted 3 specific use cases, one having to do with embedded machine learning and AI and safety. And then I deep dived into HPC. So I think we are very serious about that. In fact, my company is very deeply into using supplying SYCL to both HPC and non-HPC customers in terms of automotive and embedded vision. And I know that other people are going to have other things to add to that. Thank you. So yeah, they are all important, and we have the relevant expertise, I think, in the committee to handle that.
And go ahead, Ronan.
Yeah, what I think that SYCL does very well is to express heterogeneous computing in C++ and how to introduce some extensions with C++ constructs. And that's all what the embedded world is about. And that's what for example, we are experimenting at Xilinx with FPGAs and CGRAs and other weird accelerators where you really need a very fine control of everything. So probably there is a long road to have this well spread, probably because in the embedded world, the culture is very C oriented or VHDL or RTL stuff. So that's probably we need some experiments, but that's good.
Thank you, Ronan.
So can I ask a question? James, did you put this question up? Was this your question? James?
No.
Oh, okay.
No.
No.
No, I see. I wondered, why'd you ask that? It says anonymous. No. That would be.
Oh, okay. Because I was watching your keynote, which I thought was great. Thank you for the shout out. Did a great job covering the use of SYCL in the XPU on the ML and AI side, and you also covered to some extent the HPC side. So I was wondering if that was also why you might have asked this question.
No, but you're correct. It's very much on my mind. This idea, XPUs are everywhere, and the true test of anything trying to help us with XPUs is to be able to address it everywhere. I think SYCL's on a fantastic track there. And I think with the multiple implementations we have for SYCL and the diverse user community, we're going to get the type of feedback that's necessary to really get this right.
Okay, all right.
Good. Aksel, go ahead.
Yeah, maybe one comment. Maybe HPC is even sort of the boring case for SYCL, because in classical HPC you have lots of nodes and most of them are the same or very similar and have one type of accelerator, one GPU from one vendor or so. But where SYCL really also excels is the ability to just use lots of different devices together. And for example, that happens already regularly in common notebooks. For example, you have maybe an Intel CPU with an Intel integrated GPU, and then many notebooks have an additional NVIDIA GPU or so. And with SYCL, you can program them all. And I think this is, for me as a researcher, this is almost the more interesting case, because this is where you can really experiment with heterogeneity. Whereas with HPC, okay, it's great to get good performance, but it's not the most heterogeneous use case you can think of. And other programming models such as Cuda also can handle that if you happen to have an NVIDIA cluster.
Great point. Thank you. Well, we don't have an awful lot of time left, so I'm going to see what question we've got coming. There's quite a fun one, I think, to do with which SYCL 2020 feature caused the most discussion and disagreements during the standardization process. So who can comment on that?
As chair, I should not comment on that.
Very diplomatic.
We were always friendly.
Yeah. We had a lot of discussion about simple stuff, such as when two SYCL objects are equal or not, or I remember when do we copy back data to the buffers, and I think this one is still unsolved, but we need probably to wait C++ to make progress in the ranges stuff. That's what top of my mind.
Aksel, go ahead.
I think one discussion that I remember quite vividly is whether ranged accessors, whether a get pointer from an accessor or ranged accessor should point to the origin of the buffer or to the beginning of the range. And actually, we made some changes here in SYCL 2020. But as Ronan said, most of those are like small technical details that most users wouldn't probably even realize. But I think the really important point is that these are all technical discussions. And when I got into the SYCL working group, I was wondering, okay, there are a lot of companies, are they like fighting for who gets their agenda through? But it's not at all like that. It's really everybody wants to advance SYCL and wants it to make the best it can be. And it's all at a very friendly and technical level.
I will say that I've had a lot of experience in my couple of decades being part of many different kinds of standards and consortiums. And I have to say that the SYCL group, besides being some of the most talented people I have ever worked with, they are also some of the nicest people. We have earnest, challenging discussions, but at the end of the day, we always are trying to seek consensus that carries everybody along. So I'm really proud to be part of this group.
Great, thank you, Michael. We've got one more question for the audience. So Tim, if you're there, this might be a great time before we run out of time to bring up the last question for the audience. So why don't we do that? We've got our last poll. It's a quick fire round. Check the box if the answer is yes, and it's multiple choice. So have a quick go at that one. Have you already tried SYCL 2020 features? Have you seen the spec? Have you tried multiple backends for SYCL? Have you attended a hands-on introduction to SYCL tutorial? Have you viewed the SYCL State of the Union talk, or none of the above? So it'd be great to get some feedback from the audience on that one. I think I note as well, while you're all doing that we've ended up with 2 more participants today for the SYCL panel than we had yesterday for the OpenCL panel. So I think SYCL can take a sort of moral victory in winning winning the battle of the APIs at the conference this year. It's the first time that's happened.
Actually, Simon, did you get a chance to show your usual graph that shows where all the different languages are?
I did that yesterday, actually.
Okay, good.
Yeah, so I maybe incorrectly assumed that a lot of people here today may have been here yesterday, but I'll circulate that.
Ah, yeah, that'd be great. I always look forward to that graph.
yeah, okay, well, I will circulate that. So we just got a few minutes left. Oh, we had the poll results, there we go. So more than half of people have tried SYCL 2020 features and seen the spec and tried multiple backends and been to a tutorial. Over a third have seen the State of the Union. Wow, okay. Well, I think all of those are higher than I might have expected. So for the size of the audience, that's really interesting. Okay, cool. Thank you. And again, I think we'll get the results from the polls will be in the video. So when the video gets posted online, I think the video for yesterday's panel's gone online today. Hopefully the video from this will go online tomorrow. Let's see, we've got 2 quite technical questions. There might be quick answers to these we can get in before we finish. Is it possible to bind device cache memory levels to work groups? Something like device cache affinity domains for work groups? Is anyone able to, is that a yes or a no answer? That's the top question from Nikolai. That might be a bit too technical this late in the panel. We might need to look that one up, and Nikolai, and get back to you.
Yeah, Nikolai, send this, put this question up in the GitHub, and I'll make sure that it gets discussed in the working group. Because we don't know the answer to this. Yeah, but we will hopefully.
Yeah. Thank you. We're not going to know the answer to all the questions, but we can at least we know the right people to ask if we can't answer it. Then the second one: when will SYCL define a C API to help with bindings for other languages like Fortran or Python?
So this is a good one. A SYCL C API, is that kind of like OpenCL? I mean, that's the whole thing. Our whole philosophy is about to be as close to C++ as possible, including the single source, where we only deviate where we have to deviate. So, but that's the thing that I want to hear the rest of the committee. Is it like to make SYCL go to C++ being C++ and then go back to C? Does that mean we are now essentially reverting back to OpenCL? I'd love to hear the rest of the group, but yes, that might be one way to get that interop with these other languages. And I know Python is high on the list, and so is Fortran. What do you guys think?
I'll just express a very quick opinion here, which is that you might find that by the time you would define such a thing, it would be irrelevant.
I know, wouldn't it? Yeah.
Because there are many, many use cases for binding Python to things like C++ libraries, and the technology out there to do that is rapidly improving. Yeah. So you might find that by the time you could standardize an additional interface and figure out what it did and how it would bind and how it would work and everything else, you might not need it.
And I would say that I actually answered this exact same question in the advisory panel that Tom Deakin chaired. And my answer was that, well, if it's Python and if it's machine learning stuff you want, we're trying to do that into base C++ through the SG19 machine learning group that I'm chairing. And we're adding things like statistical functions, differential calculus, graph-based adjacency matrix and nodes. So at some point, we're hoping that will totally replace, so that everything just stays in C++ rather than having to switch out. Fortran, well, maybe we need something else that supports column-based or vectors and matrices, but I mean, I don't know. I mean, that's what I'm thinking. Other people, I want to hear a lot of it, because this does come up a fair bit.
Go ahead, Peter.
Yeah, I agree with the opinion so far. To some extent, basically, we discussed previously how everything is oriented around matching C++ in SYCL. So you kind of lose that entire foundation. And at that point, I also think that then trying to keep that additional C interface on feature parity with SYCL would greatly decrease the speed at which SYCL itself can evolve. So I see quite a few drawbacks to doing that as well, potential drawbacks.
Well,
Maybe
as
what yeah, go ahead. Sorry, James.
I was going to say, as negative as everybody is on adding C interfaces, by the way, I agree with the negativity there. I think we will see ways to take advantage of SYCL from Fortran and Python. I think there are other routes to that. So I don't think just the fact that the committee's all, or the panel's all saying no to the C interfaces, the idea that SYCL should influence Fortran and Python programs, I think that's very much of interest, and I think we'll see a number of different ways explored there. And I ultimately think that SYCL will have an effect on Python and Fortran, a positive effect on programs written in those languages.
Let me just say a quick +1 to that. It's a very important use case for us.
Yeah.
It's just a question of whether it goes in the standard or not.
Yeah, and what's the best way of doing it? Like maybe what we need is to do a single source OpenCL, you know?
With that, unfortunately, we're out of time. So Ronan, I can see your hands up, but unfortunately, I think we're just going over our time limit. I'd like to, first of all, thank you, panel members, for being here and fielding all of these really interesting questions. I know that the audience always really appreciates this, so thank you very much. Thank you to all of you in the audience. Thank you for the great questions. Thank you for stimulating a really interesting discussion. Don't forget, all of the IWOCL and SYCLcon material is now online, so you can go and find all of the talks on YouTube. The proceedings are now online as well, so you can find all of the slides and so on. And do make the most of this. There was a really great set of content this year, so do go and enjoy all of that. Make sure you watch all of the talks. And stay in touch. I mean, we've mentioned some of the ways that you can be involved. We really encourage you to get involved. Get involved in the advisory panel, get involved in the standard, submit issues, and just talk to people and enjoy where the standard is going as it continues to evolve. So thank you very much, everyone. Thank you
very much, Simon. Thank you. Every year, it's great to have you back leading us.
Thank you. And of course, thanks to Tim as well, who does all the organizing. So
thank you to Tim.
90% of this, actually, Tim Lewis does all the organizing. So thank you to Tim.
Thanks,
thank
Tim.
you very much for joining us, everyone.
Bye.
Hopefully see you in person next year.
Cheers.